How does C++ connect to hardware accelerators for robot AI? Imagine building a robot that can see, think, and react in real time. How does the software make that happen so quickly and smoothly? That's where C++ and hardware accelerators come into play. C++ is a popular language in robotics because it offers fast performance and precise control over hardware. But connecting C++ to specialized hardware like graphics processing units or field programmable gate arrays requires some clever techniques. In robotics, hardware accelerators are designed to handle specific tasks faster than the main processor. For example, graphics processing units excel at image processing and machine learning inference. Field programmable gate arrays can be customized for tasks like sensor data filtering or signal processing. These accelerators speed up operations that would take too long on a standard central processing unit. To connect C++ to these accelerators, developers often use robotics software frameworks such as Robot Operating System 2. These frameworks organize robot functions into modules called nodes. Within this setup, hardware acceleration features are integrated as separate nodes or components written in C++. This way, C++ programs can send data to the accelerators and receive processed results without needing to understand the hardware details. Another key tool is Application Programming Interfaces, or APIs. These APIs act as bridges between C++ code and hardware accelerators. For example, application programming interfaces provided by hardware vendors allow C++ programs to initiate tasks on the GPU or FPGA, manage data transfer, and retrieve results. These APIs often include libraries that make it easier to write code that interacts with the hardware efficiently. Open Computing Language, or OpenCL, is another important technology. It lets C++ developers write small programs called kernels that run directly on accelerators. These kernels perform specific calculations, like image recognition or matrix operations. The C++ code then calls these kernels, offloading heavy computation to the hardware. This process improves speed and reduces power consumption, which is essential for robots operating in real time. In practical terms, a robot's perception system might use a graphics processing unit to quickly analyze camera images. The C++ code sends image data to the GPU through an API or framework. The GPU processes the data using a kernel and sends back the results, such as identified objects or scene understanding. This setup allows the robot to react faster to its environment. Connecting C++ to hardware accelerators also involves firmware and driver layers. These layers manage communication between the main processor and the accelerators, ensuring data flows smoothly and tasks are executed correctly. Developers often use existing libraries and middleware that abstract these details, so they can focus on writing efficient C++ code. In summary, C++ connects to hardware accelerators in robotics through frameworks like Robot Operating System 2, APIs, and technologies like OpenCL. These tools let C++ programs offload intensive tasks to GPUs, FPGAs, and other accelerators, making robots smarter and faster while maintaining real-time performance.